All right, so for our fifth function, we have the cube root function. Now, cube roots, we can actually do the negative cube root of something. So we're going to stick back with our numbers that we've been talking about for the other three functions we've worked with today. So we're going to do our x and a y. We're still going to do -1, 0, and +1. So just plugging that in, we have f at -1. That is the cube root of -1. Again, negatives underneath our cube root is perfectly fine. That just means it's going to end up being -1. So there's our first point, -1, comma, -1. Then we're going to do f at 0. This is going to be the cube root of 0, which is just 0. So it's our second point, the origin, 0, comma, 0. And then our fourth one, f at 1. This is going to be the cube root of 1, which again is just 1. So we get our last point at 1, comma, 1. Again, these 3 points, you're going to see them happen quite often. They actually is the same one we had for f of x equal to x. It's the same 3 points we had for f of x equal to x cubed. And the only difference is the way the graph looks. So we still have the point at 0, 0, +1, +1, -1, -1. But this time when the graph goes, it's going to come out, it's going to look very similar to our square root graph. It's going to come out from here and it's going to do a sharp turn off to the right, and it's going to do the same sharp turn off to the left. So really honestly, if you go back and look at our x cubed graph, you'll notice there's actually a lot of similarity between the x cubed graph, or and the cube root graph. But remember, when we talked to, that they're kind of doing the opposite things of each other, because the x cubed graph is multiplying something times itself 3 times, and the cube root graph is asking what's the number multiplied times itself 3 times. So they really are opposites of each other. It's kind of a cool little trick there. So their graphs kind of look like opposites of each other. Again, domain and range, since it is going to go out to the left and to the right forever and ever, our domain is all real numbers. And I know it doesn't look like it's rising very much, but it is going up as it goes out to the left, to the right, and it is going down as it goes out to the left. So our range would also be all real numbers. All right, this next one is actually one of my favorite graphs. This is the absolute value. Okay, again, we don't have any restrictions on our absolute value as far as what values we can choose, so we're going to go with that -1, 0, and 1. So we're going to start off with f of x, so f at -1 equals the absolute value of -1. Remember, absolute value, all it does is make everything positive. So the absolute value of -1 would be a +1. So our first point here would be -1, comma 1. So now we're going to do the absolute, our f of 0, which is the absolute value of 0. Well, 0 is already positive, so he's just going to stay 0. So our second point is going to be the origin, 0, comma 0. And then we're going to do f at 1. And this is going to be the absolute value of 1, which again is already positive, so it's just going to stay positive as a 1. And this is going to be the point 1, comma 1. Hopefully, again, you kind of notice, and these look really similar because they look like the same values or same points we got for our x squared function, and they are the same values. It's just that the graph, again, looks a little bit different. So we're going to have a 0, 0, +1, +1, and -1, +1. But this time when we draw this out, we're going to do sharp lines. So we're going to do from 0, it's going to come out this way, going out this way. So the way I remember this is, if you notice, it kind of looks like a V. So you have the absolute value, which graph looks like a V. Now, the domain on this, since it is going out to the right and to the left forever, is going to be all real numbers. But our range, our y values being used, is only going to start at 0, and it's going to go up forever. So it would be from 0 to infinity. Okay, so let's look at our last 2 parent functions. Oops, sorry about that. So our last 2 here, are both fractions. This one is called the rational function. Rational is just a fancy word for fraction, so it is our rational function. Now with this one, we're only going to find 2 points. Part of the reason we're only going to find 2 points is because it does have a variable in the denominator, which means it does have a restriction on the domain, and that restriction is 0, because if I were to plug 0 in for x, I would get 1 over 0, and that does not exist. So we can't use that. So we're actually not going to do a 0.3 on this one. So we're just going to use our point -1 and +1. So if we do f at -1, this is going to be 1 over -1, which will end up being -1. So we get the point -1, comma -1. And we're going to do the same thing for the f at 1. This is going to be 1 over 1, which is going to give us a +1. So our second point is going to be the point 1, comma 1. Now this one is a little bit differently. You heard me tell you that we could not be 0 on our x because that would create a problem for our denominator. So what we end up having to do is at x equal to 0, which is actually our y-axis, we are going to create a dashed line, or what we call an asymptote. Basically, an asymptote means that your graph cannot pass over this particular line. This is a vertical asymptote, since it is a vertical line. This also has what we call a horizontal asymptote, and that horizontal asymptote lies here on our x-axis. So our graph that we're graphing cannot pass over the x-axis, or the y-axis, or the x-axis. So when we draw this graph, we're going to draw our point at 1, comma 1, and what it's going to do is it's going to come up on the y-axis and get as close as it can that direction, and then it's going to come out here on our x-axis and do the same thing. Kind of looks like an L. We're going to have this same exact shape here in the third quadrant. It's going to come close to our x-axis this way. It's going to go close to our y-axis that way. And so you've got these mirror imagings of these L shapes in your first and third quadrant. So the domain on this is going to be a little bit weird because you can use everything to the left of 0, you can use everything to the right of 0, you just can't be that value 0. So when we do our domain for this, it's going to go from -infinity up to 0, and we're going to use a union, and then it's going to go from 0 to infinity. So that's just basically skipping over that dashed line at the red. The same thing happens for our range because we can use all of these numbers coming up to 0, but we have to jump over 0 and then we can go all of the positive values. So it actually looks exactly the same. It goes from -infinity to 0, unioned with 0 to infinity. Now we're going to look at the second one. This is the rational squared function. Okay. So really the only difference between the rational function and then the rational squared function is you'll notice that the denominator is an x squared, but I still can't have a 0.3 because if I were plug 0 in for x, I would get 0 squared, which is still 0, which is undefined, so we can't use that number. Which also means for this graph, I have that same dashed line, vertical line, right at my y-axis, and I actually have the same exact line here at my x-axis. So I cannot cross over my y-axis, and I cannot cross over my x-axis. Well, let's find out where our L-shaped graphs are going to be, what quadrants they're going to live in. So we're going to go ahead and do our x and our y. We've got -1 and +1 as what we're going to use for these values. So f at -1 is going to be 1 over -1 squared. Again, remember we're squaring a negative, so a negative times a negative is a positive. That would be 1 over 1, which end up getting us a +1. So our first point is going to be the point -1, +1. Now we're going to do the same thing with the f at 1. So f at 1 equals 1 over 1 squared. So that's going to be 1 over 1, again, which is 1. Lots of 1's in that one there. Excuse me, sorry about that. So our 2 points that we're going to have is going to be at positive 1, and negative 1, positive 1. And again, our L shape is going to come up. It's close to the y-axis. It's going to come over close to the x. The same thing here in the second quadrant. It's going to come up and be as close to your y-axis. Come down, be as close to your x-axis. So you notice the differences between these two. In the rational function, your L's were diagonal from each other. One was in quadrant 1, the other was in quadrant 3 because you had your positive and your negative values. But here when we do our rational squared, our L's are in the first and the second quadrant because the second quadrant has those positive y values, and that's what happens when you square something negative, it becomes positive. So for our rational squared function, our L's are in our first and our second quadrants. Again, make sure that you've looked over these, and you do have to have these 8 graphs memorized.